Theoretical recap. The OSI model, Open Systems Interconnection, is a conceptual framework that standardizes network communication into 7 distinct layers: physical, 1, data link, 2, network, 3, transport, 4, session, 5, presentation, 6, and application, 7. Each layer has a specific role and communicates only with the layers directly above and below it. The critical concept to internalize here is encapsulation. When data travels down the stack from layer 7 to layer 1, each layer wraps the payload from the layer above with its own header, and sometimes a trailer, forming what is called a Protocol Data Unit (PDU). At layer 7, you have data. At layer 4, a segment, TCP, or datagram, UDP. At layer 3, a packet. At layer 2, a frame. At layer 1, bits. A common mistake is confusing the role of the network layer, IP addressing, routing, with the data link layer, MAC addressing, local delivery. Another frequent error is forgetting that encapsulation is reversed on the receiving end. De-encapsulation strips headers layer by layer going upward. A mini example: when you send an HTTP request, the browser, L7, generates data, TCP, L4, adds a port header, IP, L3, adds source/destination IPs, Ethernet, L2, adds MAC addresses, and the physical layer, L1, converts everything to a signal. This stack is your pile of diapers. Each layer wraps the one above it, just like nesting Lego bricks. Workshop brief. This workshop is a virtual Lego-style construction activity in which you will manually simulate the encapsulation and de-encapsulation process of a network packet traveling through the OSI model. Your goal is to build, brick by brick, the full PDU stack for a realistic communication scenario, then deconstruct it from the other end, exactly as a receiving host would. This activity directly follows your introduction to the OSI model and builds on your earlier work observing ICMP packets with ping and associating IP addresses with network equipment. You are expected to apply everything you have learned so far about topology, IP addressing, and packet structure. Scenario: you are a network analyst at a small company. A developer on your team asks, "What actually happens, layer by layer, when my browser sends a GET request to https://internalapp.company.local hosted on a server in the same LAN?" Your mission is to document and visualize the complete OSI encapsulation stack for this HTTP GET request, from the application layer down to the physical layer, and then describe the de-encapsulation process on the server side. You will produce a structured visual artifact, a diagram, a table, or an annotated Lego brick mockup using any tool of your choice, and a written explanation justifying each layer's contribution. Concrete steps. Start by clearly defining the communication scenario. Identify the client machine, the server, the protocol used at each layer, HTTP/TLS at L7, TCP at L4, IP at L3, Ethernet at L2, etc., and the relevant addressing information, IP addresses, MAC addresses, port numbers. You may invent realistic values. Next, build your encapsulation stack. Represent each PDU layer by layer, showing what header information is added at each step and what the PDU is called at that layer. Your representation must cover all 7 OSI layers, even if some, like L5 and L6, require you to think carefully about what role they play in an HTTPS exchange. Then, flip the diagram and describe the encapsulation on the receiving server, which layer processes which header, in what order, and what happens to the payload at each step. After completing the stack, write a short critical analysis, minimum 200 words, addressing the following questions. Which layer is most relevant to a cybersecurity analyst performing a web application PenTest, and why? At which layer would a firewall typically operate, and what are its limitations? How does encapsulation affect what Wireshark displays when you capture traffic? Finally, reflect on one real-world attack scenario. For example, ARP spoofing, IP spoofing, or a man-in-the-middle attack, and identify at which OSI layer it primarily operates and why that matters for detection and defense. Submission and timing. You have 2 hours to complete this workshop. This is a focused, hands-on exercise. The time limit is intentional and designed to encourage decisive thinking rather than perfectionism. You must submit your work before the deadline expires. Your submission must include 1. Your encapsulation/de-encapsulation visual artifact, 2. The layer-by-layer justifications, and 3. Your written critical analysis. You may submit as a PDF, a structured document, or a shared link to a diagramming tool, Excalidraw, Draw.io, Canva, etc. Advice to overcome difficulties. If you are unsure about layers 5 and 6, do not skip them. Research what TLS and session management contribute in an HTTPS flow. If you struggle to choose a diagramming format, start simple. A 7-row table with columns for layer name, PDU name, protocol used, header content added, and role is perfectly sufficient. Do not over-engineer the visual. Clarity and accuracy matter more than aesthetics. If you are blocked on the critical analysis, reread your previous lesson on the OSI model and your notes from the Wireshark ICMP observation exercise. The connections are direct.